Welcome and thanks for today's presentation opportunity. So who I am, my name is Maike and I got my PhD in rehabilitation robotics in 2018. And after that, I started to work within construction robotics at Lund University in Sweden. And one of my research interests became the Bettan robot, which I will present today. So you see it already on the pictures here. And the robot is developed within the Swedish Center for Construction Robotics. And here we have an interdisciplinary consortium. So it consists of computer science, automatic control, architecture, construction management, production, and structural engineering competences. And the center was founded in 2018 and is also located in Sweden, in Lund. So there are 3 robotic solutions the center includes so far. There is a self-developed parallel kinematic manipulator I presented last year at ISARC. And we have a commercial robot dog used for visual inspection on the construction site. And we also have this out-of-the-shelf components industrial robot mounted on a mobile platform, which we use so far for block handling, mortar application, or glue in this case, and sawing. Here you see the robot and the components. So the robot we have mounted on a former spindle crane platform. So we dismounted the crane and put the robot on top. And we also designed a gripper for the blocks, for handling of the blocks. And we also attached an extruder for the mortar, and we connected the hose completely to the robot. And the end effector also contains a vision computer and a camera. And everything you see, the big black hose is connected to the controller, compressor, and power, which stands next to the robot on the side. So besides a whole bunch of challenges, there are also challenges to the market from the Bettan perspective, so from the robot perspective. And one, for example, is the robot manufacturer. So there is still no industrial robot branded for the construction environment, which we could just use. So, but the overall question we want to investigate right now is if an out-of-the-shelf robot adapted for construction tasks is a feasible solution or not. Here you see a little bit of how the masonry with this Finja Exakt block system works on site when it's performed manually. So we have, of course, brick handling for the first layer or door openings. Then we need to saw blocks on site. We apply mortar with a specific device. And we also need to apply reinforcement every third layer and customize for cabling on site. And what we have selected experimentally is as a first step that we look into the manual building process so the strategies of blocks, for gluing, for sewing, as well as transport, logistics, cleaning, and setup. Here you see, so for building a whole house, we also need some digital preparation. For example, we had to decide where to place a robot inside the house to build a little bit, because we try to have as little robot positions as possible to not have so much wasting time for robot movement, for example. We also had to decide where to place the blocks or pallets of blocks and in which order we need to pick and place the blocks. Here you see the robot just moved to another position and is building a part of another opening. So next. And here, so we did a lot of tests inside the lab, and then we brought the robot outside. First test outside was more about the logistics and first experiments. And here you see the robot is taking out one of the spider legs. And the second test was more about gaining more experience and the deployment. Here we place one of the blocks. A block is about 20 kilos into the saw. and start. So take it out. And we started to build some straight wall segments in our first test. Here you see the first layer of one wall segment, which we have placed down with the robot. There we apply some mortar on the blocks. So the inner side of the blocks is isolation, so we place it outside. And then we place another layer of blocks on top. So this is a tiny part of our first wall. Then results. So it is like, so the results we got, they contain, it's a little bit about results and a little bit about future work, because we think it's kind of a gray zone. So what we can say, for example, is for the transport, the logistics, a container worked very well. So we put everything into a shipping container and put it out to the construction site. Then we could use the robot and had all the sensible stuff like the controller inside the container. And for example, so there are a lot of categories, but I just pick one now. So the mortar application. So now we have attached the hose to the robot, but for future, we think it will make sense to just have the hose connected at the end effector and have more stationary system. So now it jumped over here. So conclusions. So what have we learned so far? So the questions we asked ourselves in the beginning was if an out-of-the-shelf robot, industrial robot, is a feasible solution or not. And what we can say so far is that from a technological point of view, it works. So we could bring the robot outside, use it, clean it, pack it afterwards. So this worked. But there were some more aspects for future, also some non-technical aspects like the climate impact or sustainability, which we need to investigate within our center now to see if the whole bunch of parameters gives an answer that the industrial robot on the construction site is feasible. And here in the middle of the slide, you see a picture from another project where we build a fireplace with the Bettan robot. And there we realized that the preparation process for the blocks or the bricks and the mortar is very, very high. So we have to see that we can reduce this so that we put more effort now in the supply processes. And because cleaning takes less time. And now I will thank you for listening and hope you enjoyed it. And please feel free to ask some questions to me now or later.